All right, so now we're going to do a review of limits at a specific point. All right, so this is going to be a little bit different than what we just did. So when we are doing limits involving infinity, we're really looking for our end behavior and what's happening. Now, in every one of those, x was approaching either infinity or negative infinity. On all of these, as we approach a point, all right, x is approaching a specific value. All right, so it's not going to be approaching infinity. So whenever we do limits involving a specific point, okay, there's three things you got to be thinking about. Number one is always go with direct sub. All right, direct substitution. So if you can plug in a number and get out an answer, you're all done. That's the easiest thing to do. All right. However, most of the time, especially on problems that I'm going to be giving you, they're going to be a little bit harder than that. All right. They're not going to be as simple as direct sub, but that's still the first thing you always want to be thinking about whenever you're trying to find limits. Can you just plug something in and be done with it? Let's say you plug a value in. All right. You're going to get either a nice answer or one of two answers. If you get 0 divided by 0, all right, what you're going to need to do is then finagle. Okay, so we get 0 divided by 0, finagle, so we're going to kind of manipulate. Typically, a lot of factoring is going to be going on, maybe multiplying by a conjugate, that sort of thing. Okay, once you typically finagle it, stuff cancels. All right, then you can go back to direct sub and you're going to get an answer that usually works out. All right, the third one then is going to be you could get a number divided by 0. Okay, remember if you get a number divided by 0, what this is going to be is a vertical asymptote. All right, so what you're going to have to do then is sign analysis. All right, so those are going to be your kind of your three steps every single time when you're doing limits at a point. All right, number one, direct sub. If it works, you're done. Okay. Then if it doesn't work out, you're either going to get 0 over 0 or a number divided by 0. Okay. 0 over 0, you're going to finagle it, try to factor, cancel, that sort of thing. If you get a number over 0, then you basically are going to have to do some sign analysis to figure out what you're going to be approaching. All right, so take a minute, pause the video, write down all these problems. I want you guys to try them again on your own. Okay, so let's take a couple minutes there. When you're ready, I'll walk you through the problems. All right, so let's begin with A, shall we? All right, so guys, if I plug 6 in, okay, I'm going to get 36 minus 36 divided by 6 minus 6. All right, which is going to make 0 over 0. So when you're doing these, make sure you never ever write equals 0 over 0. Make sure you write doesn't equal this. All right, either way, let's say if this were free response on the AP exam, all right, they're going to take a point away from you. Okay, it does not equal 0 over 0. Okay, 0 over 0 is undefined. That's not what the limit equals. What we're going to have to do then is try to finagle this. Okay, so remember, you got to write your limit every single time until you do your direct sub. Once you do your direct sub, then you're good to not write your limit anymore. So for here, this is going to be the limit. All right, hopefully you recognize on top, it's just difference of squares. We got x plus 6. We've got an x minus 6, all divided by x minus 6. Okay, and x is approaching 6. So what happens here is my x minus 6 is canceled. I'm really going to be left with x plus 6, at which point I can do my direct sub, which is going to give me 6 plus 6, making 12. All right. So the first limit is just going to be 12 on that one. On the next one, if I were to plug in a 6, I get 6 plus 6. All right. On the bottom, 6 squared is 36. 6 times negative 12 is going to be negative 72. and then plus 36. So I end up with 12 over 0. All right. Make sure we never ever write then equals 12 over 0. Make sure we don't ever write 6 plus 6 over all of that stuff. All right. If we write that, then you could lose your point on the AP exam. All right. So as we go forward here, this is going to be a vertical asymptote. Okay. So I still want to be able to factor this and see what's happening here. So I've got t plus 6 on top. On bottom is going to be t minus 6 squared. Hopefully we factored that correctly. Okay, so when I do my sign analysis, the two numbers I care about are going to be negative 6 and positive 6. We can plug in maybe 0. 0 is an easy one because you go back up to your original, you end up with 6 over 36. Okay, so at 0 we're going to be positive. I really only care about the 6 side, so 6 occurs how many times? All right, that vertical asymptote came down from here twice. So even multiplicity, so we're positive here. We're going to stay positive there. Okay. Well, just for fun, let's figure out negative 6 one out. All right, so negative 6, x-intercept only occurs once. Okay, if it only occurs once, we're going to switch signs for even or odd multiplicity. Okay, so we were positive, now we're going to be negative. What I'm really looking here is this is as t approaches 6 from the left. This is 6 as we approach it from the left. What's happening here is we're approaching this vertical asymptote. All right. This is all going to equal positive infinity then. All right. So on C, all right. So guys, maybe when you plug into your direct sub, maybe you want to write something like numerator. Okay. Maybe you want to write denominator. Okay, so I plug in 8 to the third. Oh, yuck. 8 to the third is, I'm going to factor this. I got x times x squared minus 16. All right. So now when I plug 8 in, this is going to be 8 times 8 squared is 64 minus 16. These are going to be some pretty gross numbers. But anyways, if I check out my denominator, I've got 8 minus 8, which is 0. Okay. So my denominator is going to be 0. This is obviously not going to be 0. It's just going to be some really gross number that I don't want to do. So once again, we're going to have a vertical asymptote here at 8. Okay. So maybe you want to completely factor that now, where we get x plus 4, x minus 4. So when you go ahead and do your sign analysis, we're going to care about positive 8s. Okay, and the other things we have on here are going to be 4 and 0 and negative 4. Okay. This is our only vertical asymptote, though, at 8. All right, so now when I do my sign analysis, maybe I want to plug in some really, really big number. All right. So if I plug in some really, really big number, this is going to be positive on top, positive on bottom. We're going to be positive here. 8, my vertical asymptote is only occurring there once. All right, so it's odd multiplicity, so we're going to go from positive to negative. Now in this problem, guys, it's asking you as x approaches 8. All right, so as we approach 8, we have to approach the same value. Otherwise, the limit does not exist. All right, so the answer to this one is the limit does not exist, or DNE for short. Okay. If we were just approaching 8 from the right, then it would have been positive infinity. If we were approaching 8 from the left, then it would have been negative infinity. But we want to know as we approached 8, which is not the same in both directions, so the limit does not exist. All right, so for D, all right, so this is going to get a little bit tricky, some algebra going on here. Guys, our numerator, I've got square root of 16 minus 4, which is 4 minus 4, which is 0. All right, our denominator is going to be 16 minus 16, which is 0. So we've got 0 over 0. So what we're going to need to do here is finagle a little bit. All right. So let's go ahead and finagle. I'm going to create some more room here. All right. So we go ahead and try to finagle this. You got a couple different options. I always just like to factor it. I think that's going to be the easiest. So hopefully you guys recognize that this is going to be the limit as x approaches 16. So the bottom is really different. The square is factoring. It's just kind of gross looking. Okay, one gets a plus, one gets a minus. On top, I still have the square root of x minus 4. On bottom, all right, so the square root of 16 is going to be 4. That must go last. Square root of x is just the square root of x. All right, so we do all that. Then I end up with the square root of x minus 4 canceling on top and on bottom. Now be careful that you keep this in your denominator, right? Because a lot of students will end up bringing this up to the top now. That is not correct. This is the limit as x approaches 16 of 1 over the square root of x plus 4. Okay, at which point we can just do our direct sub, plug in 16. So we get 1 over the square root of 16 plus 4, which is 1 over 4 plus 4, which is 1 over 8. All right. So just be kind of careful on that one. All right, make sure you don't get an answer of 8. All right, make sure you remember how to factor this correctly. All right, so then that brings us to E. For E, guys, remember, the first thing you always do is direct sub. I plug in 0 for x. This is going to equal 2a plus 0. That's just 2a. Okay, it looks a little bit weird with having letters and variables in there, even on your final answer, but it's going to be as simple as that. Just direct sub and you're all done. All right, so let's start talking about F then, huh? Yeah. Woohoo! All right, so F is a doozy too. All right, so remember we want to do our direct sub. So let's talk about our numerator. Let's talk about our denominator. Okay, if I plug in 0 for h, all right, up in the numerator, I get 1 plus 0 all squared minus 1, which is 1 squared minus 1, which is 0. All right, so then our denominator is just 0 because h is 0. So that means we're going to need to finagle, okay? On this one, when we go ahead and try to finagle, what you're probably going to want to do is expand the 1 plus h all squared. All right, then hopefully your minus 1 will cancel, your h's will cancel, and you're going to all be good. Let's check this out. We've got the limit as h approaches 0 of, okay, so remember when we expand, this is 1 plus h times 1 plus h, all minus 1, all over h. Okay, so when we multiply this all out, we're going to get 1 squared, which is 1, plus h, which is 2h, plus h squared, minus 1 all over h. You have to write the limit every single time, all right, until you do your direct sub. All right, so then next, my 1's cancel. All right, hopefully you don't cancel those h's. What you should do first, okay, is factor out an h on top. Okay, so when we factor out h on top, then all of our h's will cancel with each other. So we've got h times 2 plus h all over h. Those guys go away. We can do our direct sub. This is now going to equal 2. All right, so All of that work just to get an answer of 2. Another thing you guys might do is recognize that this is the definition of a derivative. I don't really want to talk about that a whole lot right now. Okay. And then we'll just go into this last problem. All right, so on our last problem, we've got our direct sub again. We got our numerator. We're going to get our denominator. All right, so when we do our numerator denominator, I plug in 0 for x, I get sine of 0. Okay, our denominator is going to be 0. Sine of 0, if you think on the unit circle, okay, 0 is going to give us over here, sine is your y value. Our y value at 0 is 0. All right, so now we got to finagle it, right? Not quite. All right, so we don't know any way to finagle this one. That is where we're going to start talking about L'Hopital's rule. Okay, so L'Hopital's rule is going to be useful in cases like this where we get 0 over 0, but don't know any way to direct sub or finagle it in the direct sub. All right, so let's take a short break and I'll be right back. I'm tired.